Another type of conic is an ellipse. Now, an ellipse is shaped somewhat like an oval. It's a little bit more specific as to what kind of it is, as we'll talk about in the definition. But just so you know why they actually even came up with these, is because that's actually how the planets in our solar system move around the sun. We don't move around the sun in a circular orbit. We actually move around it in an elliptical orbit. Another thing that moves around in an elliptical pattern is electrons. So anyway, the definition for an ellipse is all the points whose sum of their distances from two fixed points called the foci is constant. Just so you know, foci is the plural of the word focus. So we have one focus, two focus, so the two foci. And the idea is, very rough estimate of what's going on here is we've got these two foci, and if you pick any point on here, the distance to those two foci from the point on the ellipse is equal no matter where you pick it. So if we add the distance of those two line segments, it'll be exactly the same as if we add the distance of these two line segments. So an ellipse is all the points whose sum of the distances from two fixed points called foci is constant. Now we do have two important pieces we have to talk about, and that's the major axis. That's the line that passes through the foci, and the minor axis, which is perpendicular to the major axis and passes through the center. Alright, so here we have the two foci. The major axis, for the way I drew it, would be going right through here. The minor axis would go right through here, and where these two meet is right at the center of the ellipse. Notice the major axis is the longer of the two. The minor axis is the shorter of the two. You might have guessed that just based on the names, but that is true. And one important thing to recognize is with an ellipse, it can be horizontal, like the way I drew it, or it could be vertical, more like this. Now when that happens, the foci are going to be this direction, meaning the major axis will be a vertical line, and the horizontal axis will be, the minor axis will be a horizontal line. But these statements are still true whether we're dealing with one that's horizontal or vertical. If you ever go further in math, you may have to deal with ones that aren't just horizontal and vertical, but that's all we'll be concerned with here. So regardless of whether we're horizontal or vertical, the major axis is still the line that passes through the foci, and the minor axis is perpendicular to the major axis, and it passes through the center. Okay, the vertices are the points where the major and the minor axis intersect with the ellipse. Excuse me. Okay, so just make sure visually we're good. There's an ellipse with its foci. Here's the major axis, so the vertices are there and there. Here's the minor axis, its vertices are there and there. So we have four vertices, two for the major axis, two for the minor axis. For the standard form of an ellipse, notice we actually have two forms. The top one, x minus h squared over a squared plus y minus k squared over b squared is equal to 1. And the second one, y minus k squared over a squared plus x minus h squared over b squared is equal to 1. And the reason there's a difference is it matters which one is bigger, whether a is bigger. Well, a is always the bigger one, I should say, excuse me. So whether the bigger number is under the x term or the y term, that's what makes the difference. That's going to affect whether we are a horizontal one, like I've been drawing most of the time, or a vertical one. And please note, since we're adding these two terms, they really could write them in any order they want. We can't assume just because the x term is written first that it's this top equation, or that the y term is written first that it's this bottom equation. The issue is not the order they're written in, the issue is which one has the larger denominator. So whichever one has the larger denominator is what matters. If the x term has the larger denominator, then you need to focus on this one. If the y term has the larger denominator, whether or not it's written first, then you need to focus on this one. So with ellipses, make sure you focus on which one has the bigger denominator. The bigger denominator we will call the a squared. The smaller denominator we will call the b squared. Okay, so first thing we're going to do is find the center of our ellipse. And this is done the exact same way it was with our circles. It turns out what we are subtracting from the x and the y is what creates our center. So one thing I probably should have written back here is that our center is HK. So that portion of it really does work exactly the same as it does with a circle. So we just look at what's being subtracted. But you will have to be careful because they may write the y first. Make sure you still put it with the y value when you're looking at that, because you got to make sure you're focusing on x first and y second, not just the one that's written first and what's written second in order. So for this very top equation for a, we have x squared over 9 plus y squared over 4. To get the center, we're looking for what's subtracted from the x and the y. Well, in a, nothing is being subtracted from the x, so that's 0. Nothing is being subtracted from the y, so that's also 0. So the ellipse in part A has a center at 0, 0. Now for part B, we got to think, okay, what is being subtracted from the x value? Well, we're actually subtracting a negative 3, because subtracting a negative 3 gives us the positive 3. So our center will have negative 3 as the x value, and nothing is being subtracted from the y, so we'd put a 0 there. And for C, we have x plus 5, so we're actually subtracting a negative 5. And for the y value, we have y plus 2, so we're subtracting a negative 2. So that's how we identify the center of the ellipses. Now, I do want to make one more example here, just so you can see the point I was trying to make about focusing on x and y versus the order. So let's say I have one written like this. I'll go ahead and tell you, what's going to be really tempting is to say, okay, I'm subtracting a 7, I'm subtracting a negative 5, and we write that as our center. But that is not correct. X values always come first. So yes, I know the y value is written first here, it's over on the left side of the equation, but that doesn't mean it comes first in the center, it's the y value. So this is incorrect. Don't do that. Make sure you're paying attention and always doing the x value first. So we look, okay, what am I subtracting from the x? That'd be negative 5. And then what am I subtracting from the y? That would be 7. We'll interact more with ellipses in part 2.